Algebra 2, Lesson 34, and this is another type of uniform motion problem. The ones that we've done in the past, we've done ones where it was D1, so distance 1 plus D2 equaled K. K is like they're going to give us a number, equals something they tell us. These ones are D1 plus K equals D2, so they're saying the distance of one person plus something equals the distance of the other person. Alright, so let's look at an example. Millicent began the journey at 6 a.m. at 50 kilometers per hour. So that goes ahead and tells us that we can say the rate of M for Millicent equals 50. Go ahead and pull some stuff out of there. Beauregard began the chase at 10 at 60 kilometers per hour. So the rate of Beauregard equals 60. Got that. And okay, so Millicent began at 6, and then Beauregard started at 10, so the time of Millicent equals the time of Beauregard plus, okay, so she started at 6, and then he started at 10. That is 6, 7, 8, 9, 10, 4 hours apart, plus 4. Alright. Then it says, what time was it when Beauregard got within 40 kilometers? So we want to know when he hasn't caught up yet. Okay, so their distances are the same. And then Beauregard starts chasing, but then when did he get here where there's 40 kilometers separating them? Okay, so the distance of Beauregard plus 40 equals the distance of Millicent. That's our main equation, and from that we're going to be able to write our rate and time, because we know we can replace distance with rate times time. So the distance of Beauregard would be the rate of Beauregard times the time of Beauregard plus 40 equals distance of M would be the rate of M times the time of M. Okay, so there's our main equation right there. Now we're just going to fill stuff in. So we've got the rate of B is 60. And then the time of B, we're not going to fill that one in. That's the one we're going to look for. Plus 40 equals the rate of M, which we know is 50, times the time of M, which we know is time of B, plus 4. Okay? Now we just have to solve this equation. So we're going to say, we're just going to bring all this down. Now we got to rainbow that. 50 times 4 is 200. Okay, and now we're going to subtract 40. Cancel, equals 50 plus 160. Now we're going to subtract this 50 right here. And we're going to get 10 TB equals 160. Then we divide by 10. And we're going to get TB equals 16. Okay? 160 divided by 10. Alright, so the time of Beauregard was 16. And remember when we made that little diagram, we said Millicent began at 6. Okay, so they're both going. Right? And she began at 6. And there's 40 kilometers separating them. And then he began at 10, so 4 hours later he started going. Alright, so they're asking us what time was it when he got within 40 kilometers. Well, it took him 16 hours to get within 40 kilometers. So we're going to say 16 hours after 10 a.m. because he started at 10. Okay, So 16 hours after 10 a.m., that would be 2 a.m. in the morning. So we got there at 2 a.m. next day. So 16 hours later would be 10 a.m. Alright. Or 2 a.m., not 10. Okay, let's try another one of those. When the sheriff began his pursuit of Robin Hood, he was already 7 miles out of Nottingham. If the sheriff traveled 6 miles per hour, so we're going to say the rate of the sheriff equals 6. Well, Robin Hood's rate was 2.5 miles per hour, so the rate of Robin Hood is 2.5. Alright. How long did it take the sheriff to catch up? Alright, so we're going to have our distance diagram. We've got the distance of the sheriff. Okay, he gets there. And then the distance of Robin Hood. And we have 7 miles out of town. So when the problem began, Robin was already 7 miles out of town. Okay? So we're going to say the distance of Robin Hood plus 7 equals the distance of the sheriff. See how they traveled? He traveled 7 more. Okay. Alright, so then we can use that to fill some stuff in. There's also a trick to this one. Their time was the same. So Robin and the sheriff began traveling at the same time and stopped at the same time. So their time is the same. So the time of Robin Hood equals the time of the sheriff. They traveled for the same amount of time. Okay, now we got to figure out how much time it was before they both got to here. Okay, it's the same amount of time from there to there. Alright, so we're going to take this equation right here, and we're going to substitute that out with rate times time. So the distance of Robin would be the rate of Robin times the time of Robin plus 7 equals the distance of the sheriff, which would be the rate of the sheriff times the time of the sheriff. Now we just got to fill these variables in. So the rate of Robin, which is 2.5, I'm going to go ahead and change that to 2 times 4. 2 is 4, 5 over 2 times the time of Robin plus 7 equals the rate of the sheriff, which is 6, times the time of the sheriff. And we're going to say the time of the sheriff is the same as the time of Robin, so we're going to replace that because we want to have only one variable. Okay. Now, this is confusing because we have this fraction in here, so I'm going to multiply everything times 2. Times 2, and multiply that one times 2. And that would make 5 times the time of Robin plus 7 times 2 is 14 equals 6 times 2 is 12. That's going to make everything a lot easier if we get rid of that fraction. Okay, so now we have to do is minus 5. And we're going to get 14 equals 7 times the time of Robin. And then we'll divide by 7. And 14 divided by 7 is 2. So the time of Robin is 2. So the time that they traveled was 2. And it was asking us how long to take the sheriff to catch up? 2 hours. So that's the answer. That one's a little easier. Alright, so practice problem. Go ahead and pause the video and try to work that out, and then I'll come back and work it for you. Okay, so there's only one practice problem. And it says, Zane began the journey at 5 a.m. at 30 miles per hour. So I can go ahead and say the rate of Zane equals 30. Okay. Tricia began to chase him at 7 a.m. at 40 kilometers per hour. So the rate of Tricia is 40. Okay. And they're saying that Zane started at 5 and then Tricia started at 7. So we're going to say the time of Tricia, no, the time of Zane equals the time of Tricia plus, let's see, well, how far apart was that? One started at 5, and then the other one started at 7 plus 2, okay? Zane started at 5, then 2 hours later, Tricia started. Okay, so there's that. What time was it when Tricia got within 20 kilometers of Zane? So if we draw this, we're going to say Zane started. Here's Zane. And then here is Tricia. She didn't get all the way to him. She stopped right here. There's 20 kilometers in between. So the distance of Tricia plus 20 equals the distance of Zane. And that's our key equation right there. We're going to use that to write our other equation. So we're going to replace the distance of Tricia with the rate of t times the time of t plus 20. Now we got to replace this one. Distance equals rate times time equals the rate of z times the time of z. Okay, so now we're going to take our rate of t is 40. Our time of t, don't know that yet, plus 20 equals the rate of z, which is 30, times the time of z, which is time of t plus 2. Okay, now we're just going to rainbow this first. So we're going to bring all this down. It'll be 30 t. 30 times 2 would be 60. Okay, now we're going to get our variables on the same side, so minus this 30. Those cancel. We're going to get 10 plus 20 equals 60. Now we're going to get rid of this 20. 10 equals 40. Then we divide by 10. And we get the time of Tricia equals 4. Alright, so what does that mean? What's it asking us for? What time was it when Tricia got 20 kilometers from Zane? Well, that's going to be 4 hours later after she left. It says that she began the journey at 7 a.m. So 7 a.m. plus 4 hours. 8, 9, 10. So what would it be if it was 7 a.m. plus 4 hours? Would be 7, 8, 9, 10, 11. 11 a.m. is the answer. So that's what you'd have to put down as your answer is 11 a.m. You couldn't just put 4 hours. Okay, that's it for lesson 34. And then we covered 2 lessons in class, so there's going to be another video.